Hello dear aspirants, this is Dr. Sourav First Classes. Our contact number is 98367 93076. Again, I am repeating our contact number, which is 98367930076, and our email id is sourafclasses@gmail.com. So if you have any mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email id, then our team can arrange a doubt clearing session for you. After that, you can join our regular batches, our one-on-one sessions and our online classes, so that will be beneficial for your preparation of upcoming examinations like ISI, CMI, and CSIR, NET, GATE, NBHM, TIFR, various entrance exams. So please feel free to contact if you need any help from us. That so then you can excel in your exams. Okay. Thank you guys. Hope you understood. So now we are going to solve a problem which is appeared in the ISI JRF question paper, and the question is telling us that suppose if we f is a function from R to R is continuous with limit extends to infinity fx equals to a, which is a finite value, and our limit extends to minus infinity fx equals to b, which is also a finite value. So with a be finite. Okay. So prove that our f is uniformly continuous. Okay. So to prove that our f from R to R is uniformly continuous, given that the f is continuous on R and our limit extends to infinity fx exists and finite, and limit extends to minus infinity fx is finite. So we proceed as follows. So the key idea of it will be what? So uniform continuity requires that for all epsilon greater than 0, there exists a delta greater than 0 such that xy belongs to R. So now, if our mod of x minus y less than delta, then mod of fx minus fy less than epsilon. So now we will split R into three regions. So they are closed end to infinity, a large positive a large positive interval, and a large negative interval which is minus infinity to minus n closed, and a compact interval which is this. So and so uniform continuity in each region. So the first step will be see about the function's behavior at plus infinity and minus infinity. So given limit x tends to infinity, our f of x is equals to a for any epsilon greater than 0, there exists n1 greater than 0 such that x greater than equals to n1, we get mod of fx minus a is less than epsilon by 2. So similarly, same thing will happen for this part also. That means limit x tends to minus infinity, f of x equals to b. Now for epsilon greater than, for any epsilon greater than 0, there exists n2 greater than 0 such that our x is greater than equals to n2. Sorry, I have written something wrong here. That is less than equals to minus n2. Okay. So then our mod of fx minus b will be less than epsilon by 2. Okay. So So let our n be the maximum of n1 comma n2. Okay. So then for x, y both greater than equals to n, we would get f of x minus f of y less than equals to mod of f x minus a plus mod of f x minus b. Okay, so that is less than epsilon by 2 plus epsilon by 2, that is equals to epsilon. So we finally got mod of fx minus fy is less than epsilon. And for x comma y less than minus n, we would get again mod of fx minus fy, that is less than equals to mod of fx minus b. Sorry, I have written a mistake here. That will be a minus fy. Sorry guys. So that will be this and plus b minus fy. So that will be less than epsilon by 2 plus epsilon by 2. So that will be epsilon. So thus our f is uniformly continuous on minus infinity to n. Let me write it here so that will be easier to see. So thus our f is uniformly continuous on these two intervals. So now we are going to understand the functional behavior on the compact interval minus closed minus n comma n. So since our f is continuous on the closed bounded, that means compact interval minus n to n, so then by the Hayne-Cantor theorem, our f is uniformly continuous on this. Let me write. Our f is continuous, okay, on the closed bounded by Heine-Borel. We can say that this is compact also interval which is minus n to n. Okay, then by Heine-Cantor theorem, we can say that our f is continuous on this given closed interval which is minus n to n. So thus for the same epsilon greater than 0, there exists delta 1 greater than 0 such that for all xy belongs to minus n up to n closed interval, if our mod of x minus y less than delta 1, then our mod of fx minus fy, that is less than epsilon. So now by combining the regions, we need to ensure uniform continuity across the entire real line. So we have to consider the transition regions near x equals to minus n and x equals to n. Now for x belongs to this, and y belongs to this if our mod of x less than y less than delta, then y is close to n. Since our f is uniformly continuous on minus, uh, since our f is on this and this, so we can choose delta small enough to ensure this mod of fx minus fy less than epsilon. So similarly for x belongs to minus infinity to minus closed n and y belongs to closed interval minus n to n, let us take delta be the minimum of delta 1 comma 1. Then for any xy belongs to R, if both xy belongs to minus n to n, closed minus n to n, then our mod of fx minus fy will be less than in epsilon when our mod of x minus y is less than delta. Now, if both x and y is lying between this, then or both our x comma y is lying between this, then our mod of fx minus fy less than epsilon when our mod of x minus y is less than delta. So fine, so good. So now if our x is lying between closed interval minus n to n and our y is lying between closed n comma infinity, then mod of x minus y less than delta less than equals to 1 implies our y belongs to mod of n comma n plus 1. Since our f is uniformly continuous on minus n to n plus 1 also, so we can write that our mod of fx minus fy is less than epsilon. So similarly we can write the same argument for this thing, and y belongs to closed interval n to n. Okay, so finally for any epsilon greater than 0, we have found a delta greater than 0 such that for all xy belongs to R, if our mod of x minus y is less than delta, then mod of fx minus fy is less than epsilon. So therefore our f is uniformly continuous on R. So we proved that our f is uniformly continuous on whole R. That means the set of the real numbers. Okay. Hope you understood, guys. Again, I am telling that if you have any mathematical queries, doubts, or anything, or any other problematic situation, so please feel free to contact on this number. Then you can get a doubt clearing session for you. After that, you can join our regular. You can join as a student to our institute. Then you can enjoy all the services of Dr. Soros classes. Okay. Thank you, guys. Hope you understood. Thank you.